or let me call it B, okay, not necessarily in B, which is such that any open set, okay, containing this set Y, okay, contains at least one point in this set B other than Y, okay? So like I said, the limit for, so you now assume you are said to be, for example, if this is a set A, you have points up to B, you assume the limit point is somewhere towards the end, isn't it? Not necessarily inside it. So that if you pick any neighborhood, supposing this is, I say this is my limit point here. That means a different marker. Suppose this is my set B, and I say this is my limit point. Is it clear? What it means is that if I take any open set containing this Y, this open set will contain some other points inside B, not different from this Y. So yes. Then you say it is the limit point of that set. So it's like a point at the extreme end of the set. Is it clear? So, but like I said, limit point need not to be limit point, sorry, mark. My remark number one is the limit point of this set B need not be in B. So it's not necessary that the limit point of B is actually a member of the set B itself. Okay? Yes. For example, now, let me give you an example. We have open interval A, B, okay? Then A and B are limit points of B, isn't it? So if my A, now it follows A and B are limit points of A from definition, isn't it? Of limit points. But you can see, however, A and B are not in A, because A is an open set, isn't it? So it's not necessary that the limit point of a subset is a member of that set. Okay. But if A is a close, so I can say now since A is open, isn't it? Since A is an open set, but if A is closed, if this A is closed, then A and B will be in A, isn't it? Yes. And we write that is A will be written now as closed interval A. Okay. A, B are still the limit point, but they are inside A now. Yes. Any questions about limit points? You are clear now what a limit point is. Okay. This will take us to our next definition. Derived set of A. A derived set of A.